Well, right triangle trig, angles of elevation, depression. Some of this, the tangent style word problems you had to like look at something from you, how like clinometer type thing. Don't leave me the chair, please. Thank you. You had to use the calculator for the stuff you did yesterday, when it looked like that. Remember that? So you had to do that. So that wasn't a big deal. Found the reference angle and go from there. Really the only other stuff then was everything kind of like on here. Shouldn't need a calculator. You won't need a calculator for this stuff. So, there's pro.
With that stuff.
Yeah.
Is with the arc where like cosine had it first and second quadrant, and
Yeah.
the other one had it like that.
Yeah. When it says when you see like sine -1 or arc sine arc, that means what angle has. So whereas evaluate cosine of 2 pi over 3, spin it to win it. Sir.
So the whole street that we had last night is no calculator?
There's nothing on here you need a calculator for. All right. It's kind of tough to find more stuff that you haven't done with the calculator. So. And I'll bring up some. I'll do an elevation problem later. On this front page, question. Jim Key.
For like 3 through 6, were we supposed to like have both coterminals?
It just said one. I just find a coterminal. I'll ask you for a positive negative.
Oh.
Sir.
Number 10.
Cosine negative 630.
I feel like I did it, but
So cosine negative 630 just means you're spinning the opposite direction. So you spin around negative 360, negative 540, and then that would be, what, another 90 degrees up? So you wind up here. That gives you a reference angle at 90 degrees. Well, what's the ordered pair there? 0, 1. What's the cosine?
X over, or no, Y over, oh, it's none.
Whoa, whoa, whoa. What's the cosine value here? 0. It's x over r, yeah. Melissa, what'd you have? Yes, sir. Anything else on the front page? You got enough?
This is more like a concept. Like I know the cosine is sine, like cosine is the x value.
Yeah.
Negative, positive. What do you do for tangent?
Y over x.
That's it.
Yeah.
So like if you go
Remember,
negative.
if your tangent value, that's your y value, that's your x value. Your theta value is y over x. That's how it works, no matter what quadrant you bounce yourself through. Okay. Oh, what were you talking about? 20?
24.
Ah, cool. 24. Find the cotangent. So if your sine value is 8 over 17, sine is opposite over hypotenuse. They're both positive, which means you have an opposite and a hypotenuse of 8 and 17 respectively. That places theta there. Means you need to find the adjacent. What's the adjacent? 15, very good. Cotangent is the inverse of tangent.
How do you know it's on the second quadrant?
Because the sine value, because your hypotenuse is the positive one, when you place it, if the sine is positive, you go first quadrant. If you place it and sine is negative, you go fourth quadrant.
Yeah, but in the second quadrant, sine is positive.
True, but when you place your sine value, if you're searching for theta, okay, when you place your theta, you place theta. So then your cotangent would be 15 over 8. Okay. For this?
No,
you
the
don't.
staggering is weird.
Is that a triple?
Yeah.
Okay. I don't remember being triple. I remember two.
The only one I remember is 24.
I remember three.
Let me rewrite this another way.
How can I figure that out without calculating?
Easy. You have to multiply things out.
You like roll with
That is the exact same problem. What is the cotangent of the arc sine of 8 over 17? It's the exact same problem. Written more like I started to show you last night. It's written in such a way what it says what angle has a sine of 8/17, and what's that angle's cotangent? I don't know. The cotangent of the angle that has the sine of 8/17 is 15/8. Show you another one. Look at 25. Tangent of the arc secant of root 13/3 means the exact same thing as find the tangent of theta of the secant of theta is root 13/3. For real, it means the same thing. So secant is the inverse of cosine. It's positive, so we'll throw it in the first quadrant. Cosine is adjacent over hypotenuse, whereas secant would be figure out the other side. So what's the tangent of that theta? 2/3. Tag right there. (13 minus 9 is 4, square root of 4 is 2. Yeah, go.
Do you go by adjacent over hypotenuse, or like x over y or y over x?
Either one means, it means the same thing. Cosine being x over r, that means secant is r over x.
Okay.
Adjacent hypotenuse, I'm just switching back and forth. So it's the same. Yeah. What, the value? Depends on what quadrant you wind up in. So if you have one where, let's see, which one would that be? Cosine 16 pi over 3. 3 goes into 16 how many times? 5. It's 5 1/3 pi. So I spin it. 1, 2, 3, 4, 5 1/3. My reference angle is pi over 3. Cosine is positive or negative in the third quadrant. Negative. So my answer is going to be negative. Well, if I have a pi over 3 reference angle, that means it's my 60 degree. Cosine of 60 is 1/2, so it becomes negative 1/2. The whole idea of spin it to win it is just to get your reference angle, draw your triangle, find the sine, cosine, or tangent off of that, and then what quadrant did you wind up in to know what sine, S-I-G-N, it is. That's the whole idea on those.
Wait, Mr. Murphy, with that, what was the step you took right after you found the angle for the fifth type of triangle?
Drew the triangle because I knew it was a 60 degree.
And then you
And what's the
just
cosine of
get
60?
The cosine of that.
Yeah. Yep, and then I figure out what's the sine, S-I-G-N. Yeah.
Is that rubber duck?
Yeah. Yeah, it's pretty sweet. Kid had it. That was awesome. Sweet. Pretty sweet. Pretty sweet. All right.
What are you talking about? Sorry.
They're on the projector.
Oh.
What else you got in here? We'll give you the other stuff then. We'll go over some of those.
I'll kill you. What? Yeah, look. And yours is always just tomorrow is your pancake day and I have to. 7 a.m. and 3 p.m. Mr. Murphy, tomorrow's free pancake day and I have to go forget it. 7 a.m. to 10 p.m.
Like just any pancake you want? Just
Yeah, you get free pancakes and they ask for information.
Mr. Murphy, is R always 0 for quadratics?
No.
I'm that really confused.
No.
It's not what is it?
No. How far off is it from the origin? Is distance ever 0?
Let's give it how far off it is from the
Here, you just remember this. No matter what, your R value is always found by x squared plus y squared. You take the square root. Will that ever be 0? Because even if it's on a quadrantal, 0, negative 1. What's 0 squared? What's negative 1 squared? What's 1 plus 0? What's the square root of 1? What's your R value? So on this one here, what I've done is I went and just kind of Googled more inverse trig stuff. And I stapled it out of order, so forgive me. On this first page here, I'm going to do a couple examples off of it. The only thing that I would concern myself about is 1 through 8, even though it says it's page number 2 at the bottom. So the first page is technically page 2. Yeah, whatever.
I'm confused. Where are we?
So I'm going to look at the problem here where it says number 6. What is the cosecant of the arctan of negative 5 over 12? This problem takes into play a bunch of stuff that we've done. It's asking you what angle has the tangent of negative 5 over 12, and then what's that angle's cosecant. So that means you have to place it into the quadrants. Tangent, when you place it with the arctan, goes first or fourth. This being negative, where am I going to place it? Fourth. Tangent is what over what? Y over x. What value is going to be negative if it's y over x for tangent? The y value. Oops. Bless you. So I know that my y value is the negative 5. My x value is 12.
13.
My r value is 13. Yes, ma'am. How do you find tangent if you're looking for an inverse tangent? It goes to either first or fourth, between pi over 2, negative pi over 2. It being negative means it has to drop and go from there. Cosecant is the opposite of sine. Sine would be opposite over hypotenuse, so therefore cosecant is? Your answer is? Yes, sir.
So in the bracket, it's basically telling you that's how you get the size, all the sides in your head for the triangle, and then you just get the cosecant for that angle.
Yeah. Yep. Look at 8. Same deal on number 8. What is the tangent of the arc sine of negative 5 over 6? Tangent, again, or excuse me, sine, in this case, you find the arc sine, the inverse sine between first and fourth. This is negative, which means I'm going to draw my triangle to the fourth. Sine is what over what? So which one of those is my opposite? The 5. So my 5 is negative. 6 is my r. So what's my adjacent? I don't know. 36 minus 25 is 11. So it's the square root of 11. Tangent is opposite over adjacent. Very good. You didn't need a calculator to solve that Pythagorean theorem there, did you? It worked out fairly well. Mr. Tuna, long time no see.
Yeah, long time no see.
These guys had a test tomorrow, they're scared.
I can see their face. They're all like, yeah.
I'll freak out. Well, not you. Oh, yeah, you too. Giovanni. Oh, it's Gios. He's in Montana's class right now. Okay.
Thank you.
Thank you, Gina.
Wish you luck, kids.
We okay? Only worry about the first 8 on this one. You actually have the answers in the bottom. You can check them. Second page, which is actually page 1. Make sure you can do 19 through 38. The rest of them are just extra duplicates and things you don't have to worry about. Okay? Just the ones that you can actually read without turning the paper sideways. And those are just, what is the inverse sine? What is the arc cosine? What is the arc tangent? Things like that. It mirrors exactly what we did in 13.4. And if you think about it, when you're trying to find the arc sine, arc tangent, and stuff like that, there's really only so many angles. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's only 13 angles. No.
Yeah, there's 3 3/4 and 4 on each side.
Do we find, when we're doing arc stuff, do we ever find anything in the third quadrant? No. Cosine is from here to here. Sine is here to here. Tangent from here to here. So, for example, I want to be able to do one like number 33. Boy, they made it really easy on you here. They didn't even rationalize it. Jerks. 33.
Wait, on which page?
I'm on the second page, which is actually page 1.
33 on here is inverse sine of 0.862.
Wow.
What? Go on the one that looks like it's answered.
Which triangle has the root 3s?
30, 60, 90.
30, 60, 90. So, which one of those is the tangent 1 over root 3? 30, but it's negative, which means it dropped to the, down here. So tangent, is it going to be 330? Is it going to be negative 30? Negative 30, very good. So it's negative 30 or negative pi over 6.
Opposite. Opposite over this.
Yeah, 30 degrees is 1 over root 3.
Oh yeah.
I was worried that I screwed something. Like, I don't think I messed that one up. It just doesn't. It's just not rationalized. Yeah, Bill.
What happens if you take me like the -1 above the tan?
Then you can't do it.
But I'm confused on like, because sometimes it does like that.
Tangent to -1 and arc tangent, they mean the same thing. What angle has?
But like, what if
You can't. Then you have to have what is the tangent of pi over 6?
but like here it's
Okay. Secant of 29 pi over 6 means what is the secant of 29 pi over 6? Not what angle has. That is the angle. What's its secant? Spin it to win it. This means what angle has tangent of -1.
Gotcha. Cosine can be in which quadrant?
1, 2.
Okay, so it's never 4.
The third page,
What are the answers to the second?
there aren't any. The third page is all the same problems.
We're super prepared for the test.
Okay.
Wait, they're the same exact problem?
Pretty much. There's, like I said, if you start looking at evaluate and find the sine, the arc, cosine, there's only so many of them that you can get. I mean, really, what did I count? There's 13 of them. There's only 13 different angles. Okay, then you have 26. There's 39 different setups if you do inverse and stuff like that.
So we'll never have to write an algebraic expression?
No, not in this. You'll do that for calc. Yes, sir.
So for 7 of the third page is arc sine of -1.
Okay.
That's a typo. And we actually have to find the arc, like inverse sine. Is that
Wait, which one do you want?
number 7?
Third page is arc sine of -1/2. What angle?
There's a
Yeah, but it's
-1.
the inverse arc sine.
Yeah.
Oh, so arc sine -1. So just the sine of.
No.
No, it's inverse arc sine. Like, does the inverse sine?
Oh, I didn't notice that.
Arc sine.
Yeah. Oh, that's a typo. Yeah. Sorry, I didn't know. I'm like, where are you being negative? Let's see the -1.
Is that
Sorry.
just sine?
It's just. Yeah, it would just be arc sine or sine -1. Yes, that is a typo. I didn't even catch that.
Where's the typo?
I was wondering what you were talking about. What are you talking about? This is what happens when you find things on the internet. They're always true. Bonjour. So then you go to the back page. Again, I want to make sure I can do 21 through 29. If I can do 21 through 29, those kind of mirror what we did towards the end of the day yesterday. If I look at 24, what angle has a cosine that has a sine of pi/6? It's working opposite from what we did a second ago. You still work through the order of operations. So what's the sine of pi/6? Well, that's a 30-degree angle, but what's its sine?
Oh, 1/2.
Yeah, 1/2.
1/2. So what angle has a cosine of a half? 60. But you're in radians, so it's pi/3. That's all. It's the same thing as we did yesterday as what's the cosine of the angle that has a sine of something. It's just working the other direction. Okay? You figure out what is the sine of pi/6. Well, pi/6 is a 30-degree angle. It's 1/2. There's my √3. Oop. And then what angle then has that cosine of 1/2? Well, cosine, if this is 30, that means that's 60. That's all it is. Okay? No. Yes. If I go back and look again at the inverse sine of the sine of 7 pi/4, or yeah. It's 7 pi/4. $224.
Yeah.
Yeah, I just worry about those the first 9 of them on there. Okay. What is the inverse tangent of the cosine of pi? What angle has a tangent of the cosine of pi? What's the cosine of pi?
0.
No, 1.
-1.
I would draw this stuff if you start yelling things out, because drawing is good for you. So the cosine at pi is -1. What angle has a tangent of -1 then? -45. Or because at this point, when you go back to here, you have to go back to the rules of your open boundaries. Okay. So it mixes them together a little bit. Yeah, just like I said, those top 9 there. Yeah, no.
I'm confused on, like, the ones from yesterday, the worksheet from yesterday. One is supposed to be one it can be negative.
What's the example you're looking at?
Like number 19.
Read it.
Sine negative 19 pi over 4.
All right. What is the exact value of the sine of negative 19 pi over 4? It being a over 4 means I'm going to wind up at a pi over 4 reference angle. Okay? I just got to figure out what quadrant do I land in. 4 goes into 19 how many times?
4.
How many are left over?
3.
So 4 3/4. So we spin it to win it. Here's 2 pi. This is on the one from last night. Sorry.
Oh, okay.
So there's 2 pi. Here's your 4 pi. 3/4 pi drops me third quadrant. I have a 45-degree reference angle. The sine of 45 is root 2 over 2, but is sine positive or negative in that quadrant? Negative. The answer is negative root 2 over 2.
Wait, so you're looking at if sine is negative?
Okay?
So if sine is negative, then the answer.
Right. The angle just tells you what direction to go. Clockwise or counterclockwise. That was on yesterday's side. It was 19. Okay. What else you got? Well, like, all right, think of angle of elevation. Angle elevation. Angle of depression.
That's where I'm at.
Angle of elevation versus angle of depression. Elevation is line of sight up. Depression is line of sight down. So if you have an angle of elevation,
Do you do this in
what's that?
Do you just play with this number every time?
So
Just
So if you have an angle of elevation, it's your line of sight up to something. And you're looking up here at a beautiful flower.
That's so pretty.
Okay?
What is it
And your
describe?
angle of elevation from your line of sight to the object is 27 degrees. You know that you are 35 feet from that wall because you can take a tape measure and put it against the floor. Your line of sight is always parallel to the ground. Okay? You know that your eyesight is 6 feet off the ground. You want to know how tall, what's the height of the whole object. Actually, I should say I'm looking at the base of the flower, but whatever, you get the idea. Okay. Well, what trig function am I going to use with an angle? It's adjacent, and I need to find its opposite. Tangent. So I know that the tangent of 27 is opposite over adjacent, so it's 35 tangent 27. Gives me my height here. What do I do with the 6 feet then? I add it in. Okay. That's an elevation, whereas depression takes a little bit longer to work with. Angle of depression, if you go through that, I'm up on a roof and,
You have a fiddle?
and I see a dog on the ground. Shut up. The angle of depression to the dog is 79 degrees. Okay? Now, angle of depression is line of sight down. So that would be 79 degrees. That means the line of sight up is also 79 degrees. When you're working with angle of depression, you're not inside the triangle that you're creating. You have to switch it to the other side to get into the triangle. That's the trick with depression. Now, I know that my eyesight was 6 feet, and I know that the height of the building was 30 feet, stuff up. How far away is the dog? What trig function am I going to use? Tangent. Sense a pattern? So the tangent of 79 is 36 over something. And then how do you solve for x when it's in the denominator when you have trig function? Just switch it. That's when you're working with elevation and depression. You have to remember with depression, the angle of depression is line of sight down, which means you have to switch to the angle of elevation going the other way. That's the big mistake people make with that. Also, if they're measuring distances, 9 times out of 10, they're talking about horizontal distance or vertical distance. I don't know if you ever try to take a tape measure and push it out and measure 10 feet. The tape measure snaps. You can't measure diagonal distance with a tape measure. It doesn't work. Okay?
If you got a reinforced tape measure.
True. There are some reinforced tape measures, like the Stanley Fat Max. You can get that sucker out there about 18 feet before it snaps if you're very steady, if you don't hold it at the wrong angle.
Your socks are pretty
Push-ups?
crazy.
You could do 13 push-ups right now.
Right now?
That sounds like a challenge.
I couldn't do it? Do it. Like, that's what you're saying, I couldn't do it?
I don't care. You can do it.
What?
I'm getting a new seat.
I know. Because you feel like you can.
I feel like I can't what? Is that what's going on?
He's giving you permission, but he's saying that he doesn't believe you have the physical capability of doing things.
But if you think you can, that's fine.
Can you?
I think you should show us.
Wait, see him puffing up? See him going like this? So he's holding his chest back. He's like, oh yeah, I can do it. What are you talking about? I got it. That's the kind of stuff you're looking at when you have done better stuff. We haven't done a lot of the other modeling style problems. There are other ones out there. I've been waiting. You know, on those worksheets you guys had where it had some of the angular speed and stuff like that, the velocities up. We wait now, since we have this modeling unit that we look at. We wait and do all that at the end. So we'll do that maybe when it's a little bit warmer out. Okay. I'm trying to think what else there was to look at. Yes, sir.
So this and what else was going to be calculator stuff?
You know how you find like the cosine inverse of negative 0.7, and then you bounce it to a different quadrant.
Oh, okay.
Is it the first page too, or this page? What is the secant of the arctangent of negative 3/5? So if I want to figure out the arctangent and it's negative, I'm going to draw it into the fourth quadrant. There's my negative 3. There's my 5. What's my hypotenuse? It's not 4. No, it's not 4.
24. Wait, can I do that?
What's 20? What's 25 plus 9?
4.
I don't think you can simplify root 34. Right. There you are. And then the secant, what would be the secant? The inverse, or the, excuse me, the reciprocal of cosine. So instead of being 5 over root 34, it's root 34 over? Yeah, root 34 5. What is the cosecant of 2 pi?
Oh, yeah.
Undefined.
Yeah, okay.
Undefined. Remember, cosecant is the inverse, or excuse me, the reciprocal property of sine. So you look at the sine of 2 pi.
He sounded like a paper shredder, like when he gets
No, I wasn't even making that noise. I was dancing
That was
because I got it right.
The clock is turning.
This is such a weird class. I'm strange today.
Today? Seriously? What's the sine of 2 pi? What's the reciprocal of 0? I'm trying to think what else I can show you. Besides, question number 3.
You can show the video, Gato.
Oh yeah, the other thing we do with cosine, with the calculators, you guys did arc length and arc or sector stuff. Area of sector and arc length. Yeah, it's really easy.
Are they going to be formulas?
I'm gonna give you formulas.
You're not giving us?
Hey.
I decided otherwise.
Wait, how's the stuff tonight? Oh.
No, that's not it. Looked at that yesterday.
How do you do the arc sector?
Well, we gotta calculate.
If I wake up on the right side.
Not arc area, area of sector. There's no arc area.
Arc length and area. You said it's not.
Remember, arc length,
Theta times radius.
angle over 360 times 2 pi r. We converted that into radians, though. You convert that into radians, you wind up with, what was it, pi?
180.
Yeah, it was theta
R.
r, so then theta was just your angle and measure, so it was angle pi over 180 times r. So you just take your central angle, you convert it to radians, and you multiply it by the radius.
Wait, that's how you find arc length?
Yeah, and then the sector was
That bottom.
it was the angle over 360 times pi r squared, which we converted into radians and wound up being 1/2 theta r squared, I believe. Is that right?
Yes.
Yeah.
I believe that's right. No, you're gonna break my chair. I understand you're really excited. That's great. Yes, sir.
Angle measure pi over 180 r. That's the.
Yeah, and that's when you do it all goes to radians. So there should be no degrees. And then you're basically taking your central angle, convert it to radians, multiply it by the radius. So if your central angle is 40, you convert it to radian, it's multiplied by your then you multiply by your radius. I'm not going to help anybody from this class in flex. You know that, right? I don't want any of you guys in flex tomorrow because of the different variations of tests and stuff like that. That way, because I know third hour tells you what's on it, and I don't. So I put the kibosh on that. I don't know who tells them, so I don't know why they even bother. Third hour tells you guys all the time what's on it. Whereas,
Nobody told me this.
well, I switched it, but it's still concepts and stuff like that. It's still the same basic ideas. So, yeah, that's all it is. 1 becomes 6, 7 becomes 2.
Page 2 becomes page 1.
Yeah, oh, you figured me out! Keep it away! But like I said, if you do have a question and you stop by in the morning, that's before school, before anybody else has seen it, by all means, stop by. I'll be here.